good evening, everyone. My name is Tommy. Ooh, I broke everything. All right. Well, my name's still Tommy, and I am a sophomore. I'm double majoring in finance and AI, and here's my project Full Stack. It's about AI agents and prediction markets. So a little bit of background. This idea came to me through a rant to my friend about my disdain for gambling and the increase in access to that. Through that, I came up with kind of a thesis that these markets are inherently inefficient because the odds aren't set by some sort of probabilistic calculation in terms of how the payout works, but rather capital allocated to either side. And so that caused me to kind of throw myself down a rabbit hole of finding out what kind of statistical calculation I can use to find sort of intrinsic probability. And then comparing that to the sentiment price to get some value or edge in the market. So for a while, this was way before OpenClaw was dropped, I was researching ways to do this. And then once OpenClaw dropped, it became a lot easier to train something on a large set of data. It became accessible for me to access a tool that can learn from itself. Moving forward into how I structured that is through two agents. If you guys don't know OpenClaw, it is an agentic AI application that runs on your computer where you can program pretty much employees to work for you. So I program two. My first one is called Agent A. And the way it functions is by scraping data from Cauchy and Polymarket, shooting that off to a model called Minimax, which is used to parse and filter that data, then comparing that to other API sources of intrinsic probability for stuff like the weather or sports or political events. And then using Sonnet, which is another model, to do that statistical analysis, and then make a decision on the trade. Then it executes itself by operating through my Cauchy account. Once that's finished, each trade is logged into a Google Sheet, and it is texted to me through Telegram the changes that happen. So that happens every hour, every day of the week. My Agent B will run every week. It's Claude Opus, which scans all the trades that are made from Google Sheets, identifies any kind of patterns or edges in my theory, and then re-optimizes Agent A by itself. So this has worked. I have a really small kind of sample size to go off of, but right now I do have a 4% edge. So it is really exciting that Agent B is actually teaching Agent A and making it more effective, to say the least. So I talked a little bit specifically about how or which models I was using. These are just the specific tasks that's done by each model. For Minimax, it does a lot of just the run work just because it's a very simple thing to do and it's the cheapest model. For Claude, Sonnet, not as cheap, but not super expensive to where running it every day, every hour would bankrupt me. And that does a lot of the statistical and like bet size and things. And then Claude Opus, again, is done with the analysis of the first agent. That is because I think that's the most important part in terms of increasing efficiency. So specifically how, what is logged in terms of what is needed for the statistics. You can see on the left here what is put into the Google Sheets, and specifically how the Telegram bot works. I created the Telegram bot myself and then gave OpenClaw the API to allow itself to text me. I had to give it my number as well. But it doesn't keep me up at night, so that's good. Agent B then texts me as well once it's done teaching Agent A what it has learned. And I can intervene at any time, and if I think something's wrong, usually I don't know more than it does, but if I think something's wrong, I can jump in and change that. So some of the problems I ran into was that I wasn't able to use Minimax initially because I gave it the wrong API, and it was just a really big problem for a long time, cost me a lot of money. because I was giving it the wrong URL, actually, not API. So that was a really nice fix to find. The data sources, a lot of the APIs can't keep up with the amount of calls that I'm doing per week, the free tiers, and the paid tiers would be too much for me to pay as a college student. There are some sites that are free, unlimited API that I found out, and other things that you can just scrape as well for free. One of them I had to find myself, that there was a problem with Agent A attributing edge in the weather market, comparing today's weather to tomorrow's forecast, which I was like, wow, 44% edge, people are really wrong about this, but it was just my model, which again was a simple fix. And then the scariest one was that I accidentally uploaded all of my APIs to GitHub briefly, which was bad because I was pretty much just giving everyone access to all my stuff. So I had to rotate them all and put them in environment variables so that they're not publicly accessible on GitHub. And then, yeah, I rotated them. And then finally, like things that I learned the most here. One of the things I picked up the AI major actually to learn. So I didn't understand it at AI at all. I thought it was like a magic box that I type all my questions into, right? So one of the things was that the LLMs aren't magic, that they are tools and that they have specific applications and there are things that they do well and some models do better than others. The dead APIs and the stale markets is what really made me come across that and using different models for different applications. The math must be real. I mean, with any kind of quantitative test that you're doing, it needs to be fundamentally sound all the way through. Security, I just spoke briefly about that. And then the cost shape. One of the longest parts was just optimizing what models to use. So, yeah, I think that's all I got. So.
Questions first from our questioner panel of former tutors.
If you had to expand this in some way, what would you do next?
So, I mean, the goal is to be able to move this off of prediction markets into the stock market. The difference is, and the reason why I think this is different from other quantitative models is not because of my math, but because of the ability of the model to learn from itself. I think that is the most important thing. There's nothing that can do pattern analysis better than an all-knowing model, right? And inherently what these models are probabilistic machines. The reason why I want to move it off of prediction markets is that I just don't like them. And I know it's kind of a weird thing to say. That's what the project is about. But I think that the stock market is where a tool like this would belong. If I can create a thesis to go along with that, then I would.
Okay.
Amazing presentation. I'd love to know more about, just explicitly from you, how this prevents bias, since often there's like bias in AI in the data it's using to train, because it comes from humans still. So can you say more about what about this is lowering the chance of bias?
Do you mean it broadly in terms of prediction markets itself, or in terms of my model, how my model interprets bias itself?
Any way you want to respond to it, because this is not my area of expertise.
Okay, yeah.
So if my question made sense in any way, I'd love to know your thoughts.
Yeah, sure. So it's more about kind of highlighting bias. So the whole thesis is that markets are inefficient because of things like gambler's fallacy. For example, the best example I can give is that in Vegas, like traditional gambling, there's a table, let's say, that has a coin flip game, right? And there's heads and tails. They both pay out. There's 49%. The casino takes 2% in the middle, right? For 49% each side. The probability that it lands on heads is still 50-50. It's a negative expected value game, right? You play a long time enough, you're not going to make money. The thing with prediction markets is the odds aren't derived from probability, they're derived from the capital on each side. So if 5 times in a row it landed on heads and people walk by and there's 10 people at a table and they say, oh, okay, 6 of them are saying, it's going to land on tails this time because it has to, or whatever reason that they give, right? And 60% of the money's on tails, in a prediction market, that if you bet on heads, you would win more money than betting on tails if it hit. So the subject to bias is what makes it an inefficient market, if that makes sense. Over here.
Hi, thank you very much for your presentation. It's really amazing. And I have a question about the success metrics of your model. Like, what's the accuracy and what's the precision?
So in order to, of my model, right?
Yeah.
Yeah, so I don't want to go too deep into the statistics because it is my edge, but I do like to keep a 99% confidence level for my plays. And the reason for that is because I want it to be a very obvious play. I don't want and the reason for that is that calculating the intrinsic probability isn't necessarily reliable, just because there are a ton of reasons why something could be happening, and it's not entirely math-based, right? So it has to be kind of an outlier play for me to consider it.